Recording in progress.
Two billiard balls, each with a mass of 0.35 kilograms. This is interesting because the problem is now telling you, okay, that you have two billiard balls. I don't know if you have played billiard before, but those balls, they all look the same. The only thing that changes is the color and the number, okay? So because they are two billiard balls, it says then that each with a mass of 0.35 kilograms. That means that the two balls are going to share the same mass because, as I say, we are talking about the same kind of balls. Okay, so the first data is given already. They are giving you the mass to be 0.35 kilograms. Both masses are the same. The reason, as I told you, is because billiard balls, they have the same shape, the same size, and they are built with the same material, so they're going to have the same mass. Now, it says that the two billiard balls strike each other head on. One ball, now we're going to separate, okay? One ball is initially moving left at 4.1 meters per second. So right now I will start by separating the givens. It says that one of the balls is initially, so it is an initial condition of the velocity. Since I'm talking of the object A, I write the given here. It says it is moving left at 4.1 meters per second. Because it's moving left, it's going to be negative. Okay? This happens because it's moving to the left. Okay? Now, one ball is initially moving left at 4.5 meters per second and ends up moving right at 3.5 meters per second. A key word here is the expression ends up. Ends up is telling me a final condition of the velocity. It was initially moving at 4.1 and in the end it moves at 3.5. Okay, so the words ends up, you can write them as final condition of that velocity. So the velocity of this object A, but after the collision, is 3.5 meters per second to the right. And because it's to the right, it's going to be positive. Now, then it says, the second ball, now we're talking about the second ball, okay? The second ball espérense. Okay, aquí me equivoqué. That is a common data. Now I'm talking about the second ball. The second ball is initially moving to the right at 3.5 meters per second. Assumed, I'm going to write this data, okay? Velocity of the object B initial is equal to 3.5 meters over second to the right, because it's right is positive. And then it says, this is important that you analyze this. It says, assume that neither ball rotates before or after the collision and that both balls are moving on a frictionless surface. All that sentence means that this collision happens under ideal conditions. Ideal conditions do not exist in real life. Now, this does not provide me of any data at all. I'm just telling you what all this sentence means. But in the end, it's giving you the instruction, predict the final velocity of the second ball. I need to find the final velocity of the second ball. So the velocity of my second ball final is going to be unknown. With all this information, I will take the equation for momentum, and I will start by writing all my data. So when you write this formula, object A, object B, object A, object B. Remember, this is before the collision, and this is after the collision. Okay? That's all you have to remember. Now, all you have to do is plug in the givens. Remember, all the masses are the same because the two balls have the same mass. So I'm going to input givens 0.35 kilograms. My object A is traveling initially at negative 4.1. Okay? So here, negative 4.1 meters over second plus object B, which has the same mass but a different velocity. Object B has the same mass but different velocity, initial velocity, 3.5 positive meters per second positive. All this is equal to what happens after. For the object A, I have the same mass, 0.35 kilograms. Velocity of the object A final. This is the velocity of my object A final, which is positive 3.5. Mass of my object B, which is the same 0.35 kilograms, and multiplying the final velocity. Okay, so here have the final velocity of my object B. Okay, now all I have to do is I'm going to solve each multiplication separately. How much do you get in the first multiplication? How much do you get from here?
Negative 1.34.
Can you give me all the decimals? Because that is an exact decimal. Negative 1.435 435 kilograms meters over second plus, how much do you get from this?
1.225.
1.225 kilograms meters over second equal to, how much do you get from this multiplication?
Negative 13.125.
Negative 1.2
13.135. 25, sorry.
kilograms meters per second. And this one, I don't work with it yet, so I'm just going to write it.
Miss,
Yes.
the one before it's positive.
Sorry. Okay. Now, I'm going to, well, I can, now take a look here. These two values are the same value. They are in opposite sides of the equal sign. Okay? So when you have this, you can directly eliminate the values because they're going to be canceled. Or you can isolate. In the end, it doesn't matter how you do it. You can cancel right now, or you can add everything. In the end, the answer is not going to be changed. So Right now, I'm going to do with you this subtraction. How much is this subtraction?
Negative 0.21.
Okay. So this is what you have so far. Now take a look. This value here is performing an addition because I don't see any sign here. I assume that it is adding, okay? So when you move it to the other side of the equal sign, it's going to be negative, okay? So this is exactly what you're going to do. You're going to isolate it. So this number remains in the same position. And the other one is going to remain negative. 1.225 kilograms meters per second equals 2. Okay. I move it to the other side of the parentheses. It was positive, now it's negative. Now tell me, what do you get from this addition of negative numbers?
Negative 1.435.
Negative 1.435 kilograms meters over second. Okay. So as I was telling you before, you can either eliminate the terms from the beginning, from here. Imagine that you had eliminate them, you still were going to have the same answer. Or you can do all the steps and you still can get the same answer. So it doesn't matter how you do it. What matters is that the isolation process is the good one. Now, this term right here is multiplying my unknown, okay? So to isolate it, all I need to do is, if it is multiplying, when you move it to the other side, it will be dividing. So that is exactly what I'm going to do. I'm going to send it to divide. So this value remains here in the upper part, but it's going to be divided by 0.35 kilograms. All this is equal to the final velocity of my object B. Now, this allows you to eliminate kilograms with kilograms. The remaining unit, though, is going to be meters per second. How much is this division?
Negative 4.1.
Negative 4.1. Is equal to my final velocity of my object B. Okay? So you can write it like this, or you can say that the final velocity of the object B is equal to 4.1 meters per second to the left, because it is negative. Okay? Either way is going to be correct. Just don't forget that a negative means that it's going to the left. The two answers are going to be correct. Now, you can check the procedure or not, but as I told you, it is an optional procedure, so it doesn't need to be checked. It doesn't really need to be checked. Freddy?
Miss, this type of problems, we always ask us for velocity or you can ask us for mass.
Look, If it asks you for a mass, the procedure will be the same, but instead of sending the mass to divide, just like we did here, you will be sending the velocity. The problem should provide you with all the data you need to use it. Now, if you have to isolate for mass, for example, for the mass of the object B, okay, that means that we need to know the velocity. We need to know this velocity. And in the end, imagine that it gives you the velocity, okay? Imagine that it gives you the velocity. Imagine that the 0.35 is velocity, okay? This is a what if, okay? So if you need to find the velocity of the object B, I mean the mass of the object B, they should give you the velocity. So when you isolate, now not the mass but the velocity is going to be sent down to divide, which allows you to get rid of meters per second with meters per second. The remaining unit will be kilograms. The rest of the procedure is the same. So whether you need to isolate for mass or velocity, it's going to give you a good answer. Okay, just check that the units match. Okay, that if you're isolating mass, the unit should be kilograms. That's all you need to be aware of. That is what if you need to find mass instead of the velocity. The procedure will be the same, just this formula will be slightly different from here. Okay, you will have the mass as an unknown and you're going to have a value for velocity, but the isolation process will be the same. And in the case of mass, you don't need to indicate direction. That's another thing to consider. But yes, the procedure will be almost the same, like 99% the same procedure. Just remember, practice with this exercise. Remember grams